Dear ladies and gentlemen, we are after a lunch break. I hope you are okay and ready to participate in the second keynote speech. Our keynote speaker is Dr. Konrad Banachewicz. He is now a data scientist, staff data scientist in Adevinta. Previously, he worked in many other companies, including eBay. You can have a look at his biography at the web page. Nevertheless, he has a long industry experience, but he also had experience with academia because he received PhD in statistics from University of Amsterdam, but he has Polish roots, as we talked, from Faculty of Mathematics, Computer Science and Mechanics, University of Warsaw. He's also probably, for some of you, quite well known as active user and Grandmaster and Kaggle, promoting some elements of machine learning and doing a lot for making it more popular. Today's talk, as you could see, the title is here, Walk This Way, AI-powered customer journey is strictly related with analyzing users and customers' behavior in e-commerce websites. I think it's better to listen to our keynote speakers than me, so please, the floor is yours.
Thank you very much for the introduction. Thank you. Since I'm hearing echo, that probably means you guys can hear me, which takes away my chance to say I signed the legislation which outlaws Russia forever. The bombing begins in 5 minutes, which is what Ronald Reagan did in '84 when asked to do a radio test. He probably induced a few heart attacks along the way, but because it didn't go live, luckily. I'm Konrad, as you have already heard, and today I'll be talking to you about, well, about selling stuff, by and large. Customer journey, that's what it comes down to. It's working. My glorious employer, which deemed my presence here worthy, is called Adevinta. And don't worry if the name doesn't tell you an awful lot. When I found out that they were the new owner of the company I was working previously, I didn't know much about them either. Turns out they're one of those companies where, well, you don't really recognize the brand, but you recognize a lot of the brands that they control. Online classified specialist, for those of you not bombarded with the jargon too much, classifieds, think Allegro. Connect buyers with sellers because we're supposed to do it, well, people were supposed to buy voluntarily and sell voluntarily. And our job as an e-commerce marketplace is sort of, we could say, 3 competing objectives. Buyers want to buy stuff as cheaply as possible. Sellers want to sell it as expensively as possible. And we, as a marketplace, we want to put them together and still make some money in the process. Not exactly the easiest of jobs, but alas. We are present in a bunch of different, it's called in the jargon, horizontals, so specialized markets. There's a job marketplace, there's cars, real estate, or buying your second-hand bicycle. And because it's 2023, I feel compelled to mention it. Because we facilitate people buying slightly used stuff, or to steal a slogan from vintage, pre-loved items. That's a real thing, look it up. That's also reduces waste, is environment friendly, etc. So Greta will not be screaming at us, I hope. Quick overview in terms of where we are present. I mean, I really wanted to do a James Bond kind of line. The first thing about Adevinta is that we are everywhere, but corporate said no. Gloomy Brothers. So you can have a look. In all fairness, we don't have US, we don't have Africa, and we're kind of cut off on Germany, so saying everywhere would be stretching it a little bit. But if you have ever interacted with, or worked in, lived in, whatever, one of the markets mentioned here, you may have run into one of those brands. This might be the component brands that all sit under this giant Adevinta umbrella. That's what it's called, that's what internally might be called tenants. And I'm only saying that not to impress, look at me how smart I am. It's just that I might collapse to jargon autopilot. And if I say tenant, that's what I mean. I don't need to flash out. By the way, in theory, Keynote is supposed to be, we do stuff and we wait until the end. If you feel like asking about something along the way, feel free to do so. I'm more than welcome that. With organizational stuff out of the way, let's proceed. Mandatory numbers, billions of visits, thousands of employees, billions of revenue. Well, not billions of countries, but as you saw on the preceding map, quite a bit. So, how does all of that connect to machine learning? I'm getting there. If you have, well, e-commerce is a business that has not the highest barrier to entry. I mean, this is not building a nuclear power plant where you need billions of investments, regulations, guarantees, etc., which means a lot of people can try and get into it. However, the number of businesses that grow to make you, the user, do stuff through them and not through someone else, number of businesses is growing much faster than the number of users. Which means a bunch of businesses present in every market you can pretty much think of are all competing for the same pie. And the question is, well, what can you do to actually do a better job, get a bigger slice of the pie? I mean, let's be honest, there's very few companies, if any, that can go for a serious, slugfest with someone like Facebook. If Facebook focuses their firepower in terms of money they have on entering a market, you're pretty much dead in the water. So, what can you do? Well, the other option is cheat, which a lot of people do. I don't think I should be advertising that for rather obvious reasons. And the first thing is be smarter than the others. Now that, luckily, is something that money can't always buy, and as the story of David and Goliath in the Bible proves, it can get the job done. So how do we do about this? Well, we want to make sure that your average user, who's just there, one of millions of potential customers in a country, he will do the business with you. So let's take an average user. He's completely accidentally called Konrad. What can we know about the user? Well, unless you are, I don't know, Facebook, TikTok, or the CIA, you can't really look at listen to what they're thinking, although Facebook is kind of on the edge there, which means we infer what the user knows. Well, closed-word assumption practically. What we know about the user is the user's interactions with our website. What did they look at? What did they delete? What did they try to buy? What did they sell? All those kinds of things. So as an example, that might be the set of preferences. Again, purely coincidental. There's preferences, but there is also the set that's a little bit harder to combine, namely dislikes. Why am I saying it's harder to combine? You have explicit and implicit feedback in what the user is doing. If this hypothetical user liked ads, ridiculous as the concept of liking an ad and not doing anything about it actually is, liked an ad, bought something, tried to buy something, okay, that's a pretty strong signal of preference that they are interested, that's something for them. The fact that I did not, hypothetical user, did not click on buying a pink bicycle. It can be because I hate pink, or because I didn't see the pink of a kind that I like. Which means the absence of a positive signal doesn't mean that's something I dislike. Which means we're running a bit of a risk. We can say, okay, if a user hasn't shown explicit preference in something, yeah, we don't care, we assume he doesn't like it. But that's not necessarily the case, and we might be missing out on stuff. This is the idealized vision of what we want the user journey to look like. If they come to our website, it's supposed to be smooth, it's supposed to be pleasant, it's supposed to be fantastic. They come in, it's a smooth, non-annoying experience. They don't have to prove, submitting a full body picture without clothes to verify that it's them. They're not supposed to set up 15 times two-factor authentication. They're not supposed to deal with spammers, cheaters, platform abusers. They're not supposed to get ripped off. In general, this is the kind of journey we ideally want the user to have through our website. Yeah, and then there's reality. So what I'm gonna walk through today is yes, it gives me the red button. This is, you probably don't see clearly the other components of the journey, but that's sort of the idea. This isn't me messing up. This isn't me messing up the color palette. A bunch of stages that a user goes through from the moment of being just a guy who opened the website or the app on their mobile or whatever, and actually getting what they wanted delivered to their doorstep, or getting it shipped and picked up by the seller. Doesn't really matter. And those are the stages of the buyer journey. Essentially, all the time you are interacting with the website, we want to help you to have as smooth an experience as possible, and we want to make sure, well, that we also make money in the process. So like, hence my earlier remark about competing objectives. So how do we go about this? Well, the first thing is acquisition. We want to acquire a user because there's, sticking to the Dutch context where I live, Marktplaats, but there's also OLX, there's to a degree Amazon, but let's not go there. There's Facebook marketplaces, let's go there even less. But the point is, they are all competing for the same pie. So we want to make sure that, first thing, we get the user to come to us. I am mostly mentioning this part for the sake of completeness, because while crucial and without it, nothing much will happen in the further stages of the journey, there's not an awful lot machine learning can do about this. This is a sort of, you could almost think of it a bit like plumbing. If plumbing is done well, you never think about it. You only think about plumbing if things go really, really sideways. And that's more or less user acquisition. If you only hear about something happening about credentials, profile security, etc., if something goes wrong. Profile gets hijacked, hacked, whatever. Important, in general, not strictly speaking for the sake of our conversation today. Ad insertion. Well, you're a user who is pro-ecological or just terrified of Greta and wants to sell something on the website, which means you need to place an ad. This is where machine learning comes in. A bunch of things that you can do about it and have to do. Actually, I should have swapped the order of those slides. Ah, that's better. I'm sorry, I'm going to be doing a bit non-linearly. What do you need to do? You need to price something. Well, you need a picture to show the person what they're actually buying. You need to have some sort of an idea how to price it. If I sell, I don't know, a dress like this, if I say it's 1 cent, all of you will probably assume, rightfully so, this is a scam to get you to click on something. If I say 5,000, well, probably a very, very weird form of money laundering. Either way, you need to know what's a reasonable range to price something. What did I say there? Yeah, product info. That one is work in progress because, well, so I don't have anything much to show yet, but the point is essentially what we are working on, and we're hoping end of next quarter in terms of our roadmap. You get a shirt, you get a skirt, or better still, something like an appliance, because then it's easier to understand, and you get all the product specifications. If you go say to Wikidata and you type iPhone 12, you're gonna get all the stuff. This is the standard stuff, battery size and dimensions, but you're also gonna get things like the whatever counterparties of the ISO code, the emission of the radiation, all those technical specifications that no one thinks that much about, but it's kind of important for the product itself. But like I said, work in progress, so not touching right now. The bit I do want to talk about is image processing. What can we do about the image here? There's a bunch of things that can happen around the image. And the main reason we are thinking about ad insertion so much, most users can't be bothered. They're like, I want to snap a picture from my phone and I want it to be the greatest, most successfulest ads ever. That's not how the real world works, but you can't tell people, bless you, that no, unless you fill everything out the way a very conscientious creator of this ad did, that's not going to happen. Which means we need to think, what can we do about filling out all this boring stuff that users frequently can't be bothered to write? They only want to snap a picture. And the thing here is, this actually does make, for once, we know better than the users what's good for them. I normally hate this mindset, but in this instance it's true. If I snap an ad and it actually does have a description of the attributes and the description here, the attributes and reasonably priced, this ad has a bigger chance of actually being successful. Someone connecting to it, clicking, starting a negotiation, yada yada. So the first thing is images. I'll come back to the textual part in a moment. This is pretty much a typical picture in terms of general quality of what you are likely to see when people are posting clothing. I mean, you can kind of see that it's a, well, general long-form clothing. I mean, I'm a man, okay? I do 16 colors on a good day, and don't get me started on fashion. The point is, you can kind of see what it is. You know that it's not a pair of jeans on a leather jacket, but that's about it. It's decent in terms of lighting. There is all this stuff around it, which, as far as I'm concerned, just makes it harder to identify what are we looking at. So the question is, can we improve this photo? And unsurprisingly, the answer is yes. For that purpose, this is the first example of what I'll be doing throughout this talk, namely jumping between business and why we do it, and the nitty-gritty of how we actually do it, with tactfully stepping over the bits in between, such as, well, there's a business objective, how do you translate it into a technical problem? The first thing we need is a good segmentation model, because intuitively, what would you do if you wanted to improve this photo? I would say, get rid of the background. So we can actually see what is it that you are selling. Which means segmentation, because we need to be able to figure out what's the dress and what's the background. Segment anything model, for those of you trying to keep up with the Cambrian explosion currently going on in AI, I think, my goodness, 2 weeks ago, or something like this, I think shortly before Easter. What LLMs are doing for NLP, so any NLP problem, you just find a big enough LLM and throw this problem in it. That's more or less what Facebook is attempting to do with segmentation models in terms of computer vision. Yada yada, decoder. Just, if you want to find out more, just type segment anything model Facebook, and then you will be redirected to the project page. The important bit, works out of the box, pre-trained on insane amounts of data, which means the segmentation problem just got a lot easier. Because if you think getting labeled data for classification or regression is annoying and tedious, try finding decent quality masks for something that does not have them. And the second thing that we will couple it with is stable diffusion. Show of hands, is there anybody who hasn't heard of stable diffusion? Yeah, okay. Generative model. Generative model as opposed to discriminative model. Discriminative model, prediction, trying to decide on a class. Generative model, modeling a joint distribution of something. Generative AI, meaning creating images based on text prompts. In this context, stable diffusion, the open source model on this front. That's like an elevator pitch of diffusion models here. The nice thing about stable diffusion is that unlike Lexica or Midjourney, it's actually open source, and it doesn't have, you know, the kind of hardware requirements that have a non-trivial CO2 footprint. How do we put these two? How do we put these two together? Why don't I see it? Yes, this is our original image. Oh, sorry, wrong direction. What I can do, once I have integrated these three in an app, which for those of you interested in quickly demoing something you're doing, look up a framework called Gradio. what you do in an app that has those two components underneath you, and that's what segment anything gives you, click a bunch of times on the shirt, on the skirt, long form dress. This is the mask that is generated. And then, can you guys read this prompt? Dress in a blue room. Okay, I'm gonna do a voiceover then. Dress in a blue room. So what I'm doing is I clicked a bunch of times here, I generated a mask, and then this is where Stable Diffusion comes in. I specify what I want in-painted around the dress. Voila, this is the effect. I mean, okay, the contrast is slightly better. I can actually see what I'm doing, but it does have a vibe of, I don't know, a rundown aristocratic residence from a movie about the 18th century. So can we improve it? Well, I can make my prompt more elaborate. I can say the wall is plain, there's nothing extra. Voila. This is the result. Hacking those two things together, stable, I mean, that's literally hacked together one afternoon, based on free YouTube tutorials, which I integrated. No, it's not banal. This is what you can get, and the very nice aspect of that, which served me well already inside the business context, it's very, very quick to demo. And I can talk until I'm blue in the face that this is state-of-the-art model. I can name drop. I can talk about Facebook this, Facebook that. Or I can give the business people a link. They go to a link, they upload their own image, click a bunch of times, and then see magic happen. Pick up that skill early on. Words from the wise. Don't learn from my mistakes, not from your own. Any questions about that part?
They don't exactly resemble one the other.
I'm sorry?
I mean, the original picture doesn't exactly resemble what you got at the end.
Correct?
That could be a problem.
Correct. I would have, in the same way that if you take your own picture, image of yourself, and you feed it to Midjourney, preserving the fidelity of your facial features is going to be a problem, which is why you have to go a bit more fancy to something like ControlNet. Yes, for much the same reason, but this is hacking one afternoon. This is not a production prototype, and something we are very much aware of. Yes? I'm hearing voices, or was there another question?
There is a question, sir.
So thank you. Well, my question is, when you showed the example of the dress before, I noticed that the back of the collar is missing in the mask, yes. And well, that's a defect that obviously maybe will be fixed in better well, data.
More careful clicking or creating the mask programmatically. Yes.
I'm afraid that many users could be well, not bothered to click there because they don't think it's important. But on the other hand, buyers, especially with more technical products, will often really appreciate the extra details. So, are these approaches only fit for the non-technical products, or rather they should be used like everywhere and perfected?
I don't know about should. Is there room for improvement? Oh yes. The kind of space you can drive a truck through.
So that's
yes.
Oh,
very much. I won't go quite as far as saying it keeps me awake at night, but yes. Sailing on, being mindful of time and stuff. The second thing we have that users frequently can't be bothered with is actually creating a description. Everybody wants to get a description of the article when they're buying something, but most sellers can't be bothered to write one, because psychology 101. What can we do about that? That stuff is pretty much so cutting edge, my fingers are still bleeding. Essentially, lovely people at whatever, Vision Kai, whatever it is, they did a, what would you call it, customized mini version of GPT-4 dedicated to a specific task. The way they pitch it, they call it conversing about an image. I don't care about conversing about an image. In the context of our business, what I care about is this. I get a picture of a model, and yes, this is a snapshot from the official demo because I couldn't get decent enough quality out of my own. So I apologize for that. For those of you who are sitting in a reasonable distance, we design image shown in the image. Can you help us write an advertisement? The mini GPT-4, you won't be able to converse with it. You can't make it your whatever, your BFF, your anime girlfriend, or your psychotherapist, but you can make it describe it, you can make it create a sort of copy for an ad, which is good enough as a first pass, because at least this is something users can work with. And in the sort of initial experiments that we've done, if you just give people something, even if they need to, I mean, there's something inducing a primal terror about the blank screen. If people have a box waiting to be populated, they go like, nah. If they have something that they need to correct, but something is already there, they are much more likely to continue. Beats me why you'll have to ask UX people, but I can't argue with the data. Another example. Why would anyone want a toucan with a light bulb is beyond me, but that's how this part works. Questions? Save note. Keep calm, carry on. Search. Next thing that people can't be bothered to fill in, and it would really make their lives easier and our lives easier, is attributes. To stick with the example of the scare that we did have here, things like, sorry, it's all in Dutch. Overige kleuren, general colors. Condition new. People can't be bothered. Because. Which means the ability to automatically extract attributes or labels. And that's a fun task in its own right, because, well, if you have a dress, you probably want, I don't know, type of fabric that's used, colors, I don't know if it's pants, jeans type or something, but you need a qualitatively different set of attributes if you are talking about a mobile phone or a home appliance, which is actually an ongoing area of, I wouldn't go as far as calling it research, but hacking our way through it, in terms of how to do it in a manner where we don't need to have a dedicated model per category, because that would kind of defeat the purpose of automatization. Ranking, sorting, yeah, it's important. I mean, that's what I call the second page in Google syndrome. If you look for something in Google, when was the last time you went further than the first page of results? Probably quite a while ago, if I were to hazard a guess, unless you are very diligent. In all fairness, I'm not. And most users aren't either, which means whatever they are looking for, that needs to be shown on the first page they are seeing, ideally near the top. Attention, low attention span, whatever. Finally, personalization recommendation, that's riffing off the accidentally called the same as me typical user. We want to find out what they like and show them what they like. For the Polish people in the audience who have seen Race, Inżynier Mam. Attributes and labels. What does this come down to? We take an image as an input. In the context of clothing, I'm using clothing because that's the one we got to work out. Primarily not so much because the data is very different, but for this one it was pretty easy to have the basic set. What's the type of clothing that we are talking about here? And what color is it? We output probabilities from this model. So what's the model confidence that this is a t-shirt and not a pair of socks? And yes, I know there can be edge cases, whether something is, I don't know, a mini skirt or an overgrown belt. And then what are the categories? Those are the ones that we use sort of in the demo. What are the colors? Given that several of you are actually studying machine learning, I won't bore you with showing a slide of code. But I imagine using a deep network for classification is not exactly, quantum electrodynamics for everybody. So we take a basic body, essentially anything that's semi-modern and will run in reasonable time. Personally, I'm a fan of efficient net, but your mileage might vary. The one thing that's useful and kind of special in this setup is that we have two heads for learning. So we don't build a separate model for category and a separate one for color, but we learn it simultaneously. Fairly simple to do in TensorFlow. disclosure, I am learning how to do it in PyTorch. What can I say? I come from the scikit-learn corner of the universe. And this is what happens in practice. Those are all for you following the good old line of trust but verify. Those are the original links on eBay. I think this presentation will be shared somewhere. Well, you look at this lady. Well, it's very clearly a skirt. It's pink. As I mentioned, I'm a man, I do 16 colors, so pink is good enough for me. The model is quite confident. I rather like this one because it correctly detected that it's supposed to be focusing on shoes. You see, it's quite confident. The white part is kind of debatable, but within the spectrum of colors that we define as possible classes, I think it's acceptable. Shoes, well, shoes are easy. I mean, confusing a shoe with something else probably doesn't happen an awful lot. So that covers the attribute extraction part. Ranking and sorting, yeah, as I mentioned earlier, Google's second page syndrome. Yeah, relevant. What a lot of people working in e-commerce will say, we want to surface relevant content to the user. Pro tip, you want to make sure any business or machine learning discussion around this topic disintegrates into something that looks like a parliament debate or worse. Ask them what their definition of relevance is. And then sit back and watch the world burn. You're going to have 3 people and 5 opinions. Having grown rather tired with those discussions, what we decided when we were building this model, more relevant equals more likely that you click on it. It's not an ideal definition because it misses out on psychology, blah, 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 but it's operational. We can actually do something about it. In particular, we can turn it into a machine learning problem. Cost-sensitive classification, yeah. This is kind of relevant from a more, what I mentioned earlier. I've been going from high-level business to nitty-gritty and then back a few times. So fasten your seatbelts. This data sets on predicting clicks will be typically extremely imbalanced. Like an average click-through rate on an ad on a big e-commerce marketplace in the ballpark of 2%. If you have 3% of ads being clicked, that's a really, really popular category. Personalization and recommendation. Ah, that's a nice one. Good way to boosting engagement, which is fancy business talk for saying we want people to click on our stuff and not the stuff of the competition, yes? Workhorse collaborative filtering, meaning, so joke like, how does Amazon recommend stuff? You bought a toilet seat last week, would you like another toilet seat? Actually, it's only partially a joke. The fact that the company the size of Amazon doesn't seem to care in the slightest to keep track of your purchases and actually change stuff, and not, I mean, okay, there may be situations where you bought one last week. Yes, I'll concede that, but it's not at all. Amazon doesn't seem to care, which I find amazing. Or then again, if you have as much money as they do, maybe you don't need to. The relevant bit, you see what users did, what they bought, that's the collaborative part, and then on that basis, that's the filtering part, predict stuff for a given user. Essentially what it comes down to underneath, you have a gigantic sparse matrix, users in rows, items in columns. If this user bought this item, then this is a 1. Everything else is zeros. Then you reduce the rank of this matrix, you do a reconstruction, and on that basis you predict. Works like a charm. It's pretty much Excel of machine learning on that front, and there's an awful lot that needs to happen beyond that. And the main reason this is important is new items. If you have a new item which has not been bought or clicked or interacted with in some fashion by a lot of people, it won't have clicks. Which means collaborative filtering, which is basing a prediction for an item based on what other people did about it, will have absolutely abysmal results. Because there's just nothing to work. I mean, an algo is not God. It can't create something out of nothing. So that's again in jargon called start problem. So, which means if we base what we show to users only on the collaborative filtering algorithm, that bases show more popular stuff, engineer mammon. I seriously need to come up with an English variant of that. It will never get surfaced. So popular stuff will get surfaced more and more, and the new stuff never will. Not what we want. Equality, yada yada. So what can we do? Option one, have a content-based recommender. So show people something not based on clicks, which is behavior, but on the attributes that even new stuff has. An image, a text, those kinds of things. Option number two, improved our behavioral-based recommender. So how do we do about this? Super quick primer. Again, show of hands, please. Who in the audience hasn't heard of word to back? Word to back. Okay, I see no hands. I'm gonna assume you guys have, so I can go quickly through that one. Basic idea in NLP. We represent words. We reduce the problem of handling words to linear algebra. It's kind of sacred tradition in math. How does a mathematician solve a problem? It takes a piece of wood and two nails in it. One hammered halfway, one all the way. He first solves the one that's all the way because it's the more interesting case. Once he's done with that, what does he do with the other? He hammers it all the way in to reduce it to a known case. And this is more or less what we are doing with NLP. We have linear algebra pretty much worked out. I mean, you look at any modern software using linear algebra, if you ever try to compare it, compile it yourself from source, what you're gonna see is a metric ton of messages from a Fortran compiler. And the reason for that is that the best libraries for linear algebra, by and large, have been written in the 70s in Fortran. And they are so blazing fast, it's still 40 years later, 50 almost, it's faster to write a wrapper around it than try to beat them in a different language. Which I think is kind of amazing in a field changing as fast as IT or AI. Swimming to shore. The beautiful part about handling problems like this, creating embeddings, we don't need any labels. The fact that we have a large lump of text, that already encodes our relationships we care about. Relationships in a sequence, blah, blah, blah. An example that's been probably overused to death and then some. And why does it matter for us? Remember, hammering all the way in. What's ads? It's words. You can think of it as words. And interactions of user, a session. I clicked on this, I liked this one, favorited, whatever the hell that means, but apparently there is something like this on Marktplaats. Like, why the hell would you favorite an ad? That's the manner of interaction with the website. And there is a logic to that. You clicked on one thing, which then, we are assuming, led you to click on something else, and then view something else. Which means we can recycle the word to vec idea. Ads a user viewed in a session are words. A session is a sentence. And that's more or less what we are doing. This ad, in the last, say, well, excluding people with compulsive buying behavior, say we take 45 days. That's a bunch of ads that you interacted with. Well, this repeated, this happened. It is a sentence. The fact that it's not a meaningful human language doesn't matter. It's still a legit, it's a legit enough language for us to pretend that it's fine and we're gonna treat it as if it was Polish or English. And that's what we use to build Add2Vec as an algorithm for recommendation for ads. The idea here is we can exploit the relationships and get some signal, in particular on ads that are new. Not an awful lot happened about them, which doesn't solve it completely, but it does alleviate the problem of cold start to a degree. Filter repetitions, signal strength. That's a relevant one. What constitutes a sentence? Just in this context. Just the fact that I viewed something, it's meaningless. I may have been shown some, textbook example. Anybody who uses Facebook knows it. Facebook algo recommends absolute junk. I mean, my personal favorite was when it recommended me, what was it? A recommendation, I think, for a preparatory course for conversion to Islam. I'm like, either it knows some really deep truths about me, or the recommendation algo is utter crap. Those are the two possibilities, pretty much. I'm going with the latter, because the alternative is too terrifying to comprehend. So purely viewing is not good enough. I mean, there's abundant signal, but it's very, very weak. On the other hand, just buying something, that's a super strong signal. I bought something, and then I bought something else. Chances are those two are related, but it's very, very sparse. There's very, very little data. Like the moment you go from viewing to purchase, 2 orders of magnitude drop in the size of data, which means there's less stuff to train. And the second problem, which is where the differences with basic word to vec come in, inventory changes very quickly. Ads come and go, people delete them, something got bought or removed or flagged, etc. all the time. Language, on the other hand, well, it does evolve over time, but certainly not from day to day. And those are the examples of what happened when we were recommending purely on the basis of collaborative filtering. This was our seed ad, so the one that we started with and said, okay, what are ads similar to this one? Maybe user clicked on this, we want to recommend them something similar because this one is out of stock, or something happened. This is what the original recommended, purely on the basis of collaborative filtering. On the other hand, when we applied up to vec, the upper image is what happened. As you can see, and yes, I shamelessly have chosen examples that actually worked, because we did have our share of hiccups. Well, I mean, image worth 1,000 words and all that. As you can see, this one is significantly more efficient. Summary. Spot checks to say the testing. Well, it actually worked. More people started clicking on stuff when we showed them this specific metric. Next step, and that's actually the nice thing about it, if we take the closed word assumption, meaning all we know or are legally allowed to know about the user is the user's interaction with our website, then we can say, okay, you as a user are a sum of the ads that you clicked, viewed, etc. Which means if we combine it, we can have a vector representation of a user that's sitting in the same space as all the ads. Linear finite dimensional space, linear algebra 101, which means users and items are sitting in the same space, and that makes personalization way easier in a fairly, I would argue, elegant manner. Any questions?
You are what you click, yes?
Hello, surveillance capitalism. That's the times we live in. Plus, I did say if we make this assumption, yes. Or I can come closer because I haven't your microphone already.
So I have a question about all these repositories and models that you are using, that you are showing us. Are these all commercially free to use?
GPT-4 is.
All right.
Okay, if the rest of you can put up with a quick rewind. This one is built internally in Spark, but Spark has word to vec built in, so this was a matter of simple adaptation. This one, ditto for this one. This is built internally in Keras, but from open source components. This one, like I said, TensorFlow, because I don't know how to head it in Python yet. This one, to my deepest pleasure, seems to be commercially viable as well. And if not, second best option, they were kind enough to provide instructions on how to train it yourself. So you're gonna have to contribute to global warming a little bit. Again, watch out for the Swedish doom lobby, but you can do it. These two are stable diffusion certainly is. I am not 100% certain about some. I have not checked this one. So, all of them, the answer is yes and one is a maybe. So I think that's good enough.
Right, thanks.
There's another question.
Yes.
Here.
Okay. I seem to have got lost around between you describing how you tokenize the description of an ad and when you show this add to add these boxes that you told that you might in Spark. Yeah. So how do you go to this from the description, or are these like two different?
Those are not related. This would be session behavior. I'm sorry, I probably should have included a slide with a snapshot of session. So yes, I should have had just a dump from the screen. But yes, you create this one the same way you would apply word to vec to a body of text.
Yes, but how do you define these boxes?
Not sure I understand. As in add x, add y?
Yeah.
Add 1, add 2, add 3. This is what we can create, the kind of representation of a session of a user. Based on our behavior in whatever the hell it's sitting right now. I think Spark SQL. Unless I am not understanding the question, which I'm afraid is the case.
Because the way I understood this, like you took the description of an ad, and from that, like this.
No, this is up. No. My bad for going too quickly. This is completely independent of the content. The description of the ad, the picture, the title, the attributes and stuff, that's under content. This is purely behavioral, purely clicks. Who clicked on what? And this is the who clicked on what. That's the source of info that we are milking for all it's worth to create this one.
Okay, thank you.
Being mindful of time, I'm gonna speed up a wee bit. Oh, okay. No, that's a luxury problem to have.
Okay, I have a question about the slide with two rankings, the one with the add to vec and the recommendation ranking. Maybe, just maybe the second one, the original ranking is not used to find the same items. Maybe it's to recommend items that the other people are looking for, which are interested in the first item. So the question is, do you have any statistics about successful purchase while using the add to vec ranking?
No, we don't. And there's a deeply unfortunate reason that does make me miserable for a long time now, but there's nothing I can do about it. And it has to do with where do payments occur. If you buy something through, say, Marktplatz, ultimately you will be redirected if it's a business seller to their website, and that's where the transaction occurs, or to a direct communication with the person who's selling it to you, and then you settle out by Blick or whatever. Important point is, we as the marketplace, we do not have that information. So we can't, I wish we could. I wish we were in a position like Amazon, because if you buy stuff through Amazon, you pay all the way for Amazon, which means Amazon controls the entire funnel. For us, what we have to use is a poor man's proxy, and like I said, and I'm not exaggerating, it's making me unhappy to no end on that front. We have to use what's called an outclick, meaning you proceeded up until the moment until you were redirected somewhere else, as a proxy for a successful transaction. As in, we are implicitly assuming, and yes, we know that's not a perfect assumption, that if you got to that stage, you're probably quite convinced to go with it. But it's not a guarantee. We might be wrong, maybe the, I don't know, end user was a horrible person, or the page of the merchant was, so disgusting that you gave up at the last moment.
Okay, so does it mean that using this assumption, you have proven that the add to vec is more successful or
yes,
more useful?
In the metrics I mentioned with here, we had an increasing leads. Leads is the phrase, not outclick. Leads. This increased when this increased to 3 when we switched to autoclick. I mean, I'm fully aware that 1.2% does not sound terribly impressive, but keep in mind, we are talking about something that as a baseline has a 2% of being clicked in the first place. Okay? So it's kind of useful to adjust for that expectation.
Okay, thank you.
Okay, let's go faster.
Sailing on. Buyer choice. We want to make sure the right people come to the website. I mean, you want the right people and not the wrong people in all your interactions in life, and e-commerce is no different. And we want to profile users. I mean, it's more benign than it sounds. We want to identify groups of customers, know what they actually want, and approach people in different manners. To give you a simple example, some people coming to the website are regular users. They buy stuff all the time. I don't know, it's their way of life. Others used to do it and then they started dropping away. Like someone used to come every week and we haven't seen them on the website in 3 months. Maybe they are slowly becoming disenchanted and about to drop off. So if we offer them a nice discount, they might come back and maybe something else happened in their life and they're just gone. And the key is knowing the difference insofar as we can. Understand what the customer wants, target them differently, extract behavioral features, because that's the only thing, we are allowed to use. Roughly speaking, users with no reply, they are just there, they don't interact with anybody. Maybe they are just shy, maybe they are just super introvert, and that's why they don't, but maybe they don't really care about buying what's going on. We try to identify them based on different behavioral features. Users who did reply, well, we have something to go with. How long since they were last here? What was their typical pattern? Like I said, if someone used to come once a month and we haven't seen them in 3 weeks, no biggie. If someone was coming every day and we don't see them for 3 weeks, that's probably a qualitative change. Extract features, group users on that basis, assign the clusters. I mean, the tricky part here, when we're building this project, and this was garden variety k-means, by the way. So we are jumping from stable diffusion and mini GPT-4 to pretty much, I don't know, prehistoric era, namely k-means. Welcome to the real world. Was it? Welcome to the desert of reality. We evaluate the relevant bit about evaluating the clusters is it's easy to build a bunch of behavioral features. It's easy to normalize them. I mean, run k-means we just converge, period. Interpreting them, that's the tricky part, because I can always run k-means and show my, elbow graph and stuff, and then I talk to people who are actually supposed to run a marketing strategy on that basis, and they're gonna go like, Whereas if I can create a prototype per cluster, so average of observations in this cluster, and it's actually interpretable in a meaningful manner, say, those are people who are about to drop off, and those are super active users. So, bluntly speaking, they are there anyways, and so we're not terribly motivated to incentivize them more. That's a different conversation. Then marketing stops thinking that data scientists are those, pale complexion trolls chained in the background or the basement, but they actually can contribute something useful. User profiling, similar thing. Extract the features, clustering for those of you interested in the tech stack. Sparkling water, namely H2O plus spark on top. I'm accelerating slightly, being mindful of time. Similar thing, as you can see, you look at the different two groups of users, differences start being visible if you look at specific features, and that's what enabled us to create meaningful interpretations of the clusters. User profilers, breakdown. Communication. As I mentioned earlier, people can be disturbingly creative when it comes to platform abuse. For the life of me, I fail to understand how in an era where everybody can have Tinder, Grindr, and whatever on your mobile phone, would anybody use communication on an e-commerce platform for hookers? It's beyond me, but it happens. And that was also my first reaction. But apart from the comedy value, it's actually a business problem. Because in several cases, hookups attempts like this are unsolicited, which means every user who is exposed to that is one more user that will potentially say, okay, I'm out of here. I'm going somewhere where I don't have to deal with this stuff. Which means we have to, clamp down upon it quickly and brutally. And at scale. That's an important bit, because unless we automate it, some poor human being, a moderator, has to actually read through that. And I once spent 5 minutes, and it was a few hours before I was able to have a meal again. So, not recommended. Which means there's a business gain and a humanitarian gain here. It's even more fun if you do it cross languages, which was the case what we were dealing with last year. The tenants I mentioned at the start of the talk, there's a bunch of companies under the umbrella. In particular, there's a Dutch arm and a German arm. And both of them wanted a moderation model for chat and internal communications. The thing was, they did not, only the Germans had the data, labeled data. Both of them had the chats, but only Germans had the labels. So we built the classification model for the Germans, okay, and then what are we going to do about the Dutch? Well, there was two things we could have done. We could sit, twiddle our thumbs, and go like, well, get us labeled data. Well, okay, we'll try to fit it in a roadmap because it doesn't fit in a sprint on Jira, yada yada. A quarter down the line, maybe they would have gotten to it. Or we could have said, you know what, we can actually spend that quarter on building a transfer learning framework. So the next time when someone comes along, we don't have to wait. We won't have to wait a quarter for them to quarter in the best case scenario. For the labeled data, we can use transfer learning. I mean, in this instance, we could get away with that because this was Dutch and German. Two languages that are pretty close to each other in terms of the family of languages. German and Chinese probably wouldn't have worked. What was very helpful to have a first pass as a sort of dirty labels on this one. Oh, I've been wanting an excuse to do that for a long time. Promote hugging face. One of the best things to happen in machine learning I don't know if since scikit-learn, but something comparable. If you are ever dealing with a problem, you need a sort of set of candidate labels, at least, dirty as they might be. You need to produce something as a sort of first pass, as zero shot. Hugging face is your friend. This is literally the... Why can't I see the red dot? The code that does it. Import model, feed candidate labels, and off you go. Balanced, imbalanced, you don't care, you're using a pre-trained model. I've been pressing something too much, so now I'm gonna have to do it on the keyboard. I'm so sorry. Moderation, like I mentioned, train on the domain with available data, which in our case was Germany. Generate zero-shot labels using something like a pre-trained, model out of transformers, and then voila, transfer learning is your friend. Trying to solve exact same problem, moderation of harmful content, which meaning multi-class and very nastily imbalanced classification. I mean, it's actually a good thing it's imbalanced because that means most people are not horrible human beings, but it makes my life harder as someone doing machine learning. And then slap transfer learning on top. Questions on this one? And yes, I know.
Time is going on, so let's go.
Okay. Know your customer. Payment methods. Some people are horrible human beings. They scam others, they want to get the money, and that's without providing anything in return. And that's where machine learning comes in the context of the payment part, meaning across all the previous stages of the buyer journey. You found what you wanted, you communicated with the seller. You agreed that this is fine. Now you'd like to know that you are actually dealing with an honest seller and a scammer. Delivery, well, tracking and status and delivery experience, that's not so much machine learning. Well, delivery experience a little bit if you want to try NLP on sentiment detection. If, the summary of your comment section is primarily obscenities, then you might have a bit of a problem with customer experience. The fun part, and that's one where we are talking about a pilot program, the company that does it, shipping recommender. Turns out, most of us are absolutely horrible at assessing how big a package needs to be, where we send something. And I'm including myself in that number, by the way. Which has a bunch of consequences. Consequence number one is immediate. You don't know, well, you might be overpaying. You purchased a much bigger package than you needed to pay in the first place. And more importantly, that means companies transport a lot of air. I mean, anybody who's ordered something from whatever, Amazon or IKEA, you probably know the giant pile of carton that's produced once you're done unpacking it. Well, it would be actually kind of nice to reduce that number. And that's what shipping recommendation is for. The idea behind this one is you take a picture of the stuff that you want to transport, and you get a guesstimate in the first pass at least, of what's the volume of the packaging that you need and how heavy it's going to be as a result. This is very much a pilot program ongoing because, well, we're lazy and we were like, do you know what, if we can start building it from scratch, and we can actually talk to people who already started doing it. Maybe see they are interested in partnering up. And Optiorix, who I'm shamelessly name dropping, is a startup that's doing exactly that. So, quick overview in a style of marketing presentations, all the keywords dropped around the whole thing. As you can see, the very act of us as an e-commerce platform trying to get you to go do your business through us and not through the big, bad, evil blue competition involves a number of interesting machine learning problems that need solving that jump between the archaic and the ultra-modern and just about everything else in between. And that's it. Thank you very much for your attention.
Thanks for your interesting talk with many aspects of real world. We are a bit out of time, so I'm afraid only one or two short questions. Comments?
Anybody interested?
There is a question there.
I will be outside. I'm not running away.
Yeah.
Unless you chase me out of town.
We will have a coffee break, and remember, conversation, coffee breaks are very important, and the question goes.
Okay, so I have the question coming back to the ad to vec and the consumer to vec, because as I understand, you only use the ads that the customer clicked on in the ad to vec. And how about sort of negative examples, the ads that were shown but got no interaction? Do you consider using this as a negative examples to shift the vector in the other direction?
Not directly, precisely because of what I mentioned earlier, the problem of interpreting the lack of interaction. It can be that they liked it, it can be that they didn't care. We don't know. That's a bit of a, what's it called? PUL, positive and unlabeled examples. You have also that problem a bit if you look at like pure supervised classification. That you have a bunch of positive cases that you know are positive, and you have a bunch of I don't knows. You know some of them are positive, some are negative, but you don't know. So no, in this instance we did not.
Okay, thank you.
So do you consider the ethics of promoting addictive behaviors, or do you consider it as a user's responsibility?
At this stage, mostly as a user's responsibility. The ethical angle is mostly handled. We handle the ethics part or focus on mostly on the what is not allowed. And you want a mini horror experience, talk to someone working in this business, ask them to show you a list of blacklisted items. Because that's like, whew, I so don't want to look at it again.
Okay, because the coffee break already started, I would like...
God forbid I should infringe on the coffee.
Okay, I will say a few words still, but let's thanks very much again.